In previous videos we've looked at building the hardware behind a simple robot and how we can use software to control simple stuff like LEDs, but in this video we're stepping it up to motors and we're going to talk about how to control their speed and direction and introduce some important concepts like pulse width modulation and how we can use all of that to get a robot moving for the first time. So let's get to it.
We're going to start by reintroducing the motor controller we used to build the robot in video 2. The part we used was called an L298, and before we dive into programming again, let's just recap how we connected it up in the first video. Unlike controlling LEDs, each motor requires 3 connections to control it. To understand more about how these connections work, we need to take a look at the datasheet for the motor controller. The datasheet tells us everything we need to know about this part, like the voltage it's designed to operate from, how much power it can handle, what the connections are doing inside the chip. The detail of how this chip works is beyond the scope of this video, but the main things we need to understand are that these 2 connections control the direction the motor spins by turning on and off certain parts of the chip, and then this connection controls how fast the motor should turn. To make the motor spin forwards, we pull one of these pins high and one of these pins low, and to make the motor spin backwards, we do the opposite, so this pin is low and this one is high. To see what this means for our software, I'm going to start by making a note of which pin is connected to which. So the 2 connections controlling the direction go to pins 2 and 3, and then the connection controlling motor speed is connected to pin 9. In the setup part of our program, we need to define each of these as outputs from the Arduino, as the signals are coming out of the Arduino and then into the motor controller. Once these are set up, to make the motor spin forward, we set the directions as we described earlier, so one direction pin is high and the other is low, and then we can set the motor turning by pulling the speed pin high. As with the LED example in a previous video, we can use delays to control the timing of behaviour, so I'm adding a half-second delay, then pulling the speed pin low to stop the motor, and remember everything in this loop function will repeat over and over again. Uploading this code, we've now got the motor running and we can control when it starts and stops. So far we can control the direction of the motor and set it spinning, but it's also really useful to control its speed, and for this we'll use a technique called pulse width modulation. Rather than keeping the speed pin permanently high for all the time that we need the motor spinning, we're going to toggle it very quickly high and low to effectively stop and start the motor thousands of times per second. The length of time we leave the motor on versus the time we leave it off will dictate how quickly the motor is spinning. This fraction of time the motor is on during each period is called the duty cycle, and in code it's represented as a number between 0 and 255. Setting the duty cycle to 0, so the speed pin always stays low and the motor is stopped. Setting the duty cycle to 255, the speed pin always stays high and the motor spins at its fastest speed. Setting the duty cycle in the middle at 127, the speed pin quickly toggles between high and low and the motor spins at roughly half its speed. We can set the duty cycle anywhere between 0 and 255 to get exactly the motor speed we want. Back in the software we control duty cycle using the analog write command, so we just need to modify the lines where we set the speed pin and we can now set it to any value we want to control speed. We can control a second motor in exactly the same way, just using 3 new pins, so let's add those into the software now. With these lines added, we've got everything we need to get the robot moving. Using these few commands, we can control the speed of the robot and also steer. By running the left motor slower than the right, the robot will turn to the left, and by running the right motor slower, the robot will turn to the right. We can even get the robot to turn on the spot by running one motor forwards while the other one runs backwards. Putting this all together, we can create sequences that will get our robot following any path we want. And that's it. I hope you enjoyed this video where we've covered some of the basics of motor control and got our robot moving. In the final part of this series, we're going to look at controlling more powerful motors for bigger and better projects. So I'll see you in the next video.